Hi there! What we're going to be working on in today's video is taking the right triangle trigonometry that we've been working on and putting it on a coordinate plane to then calculate values. So let's jump right into it. Our first example says that we have an angle that's in standard position, so that means that the vertex will be at the origin and the initial side will be here on the x-axis. And it has a point on its terminal side that's located at 4, 3. So 1, 2, 3, 4, 1, 2, 3. So that is on the terminal side, meaning the angle looks like this. Okay, so we're going to graph the point and then sketch the angle, which we have here. This is our angle, it's theta. And we're going to drop an altitude to the x-axis. So from this point, we're going to drop our altitude this way. Now an altitude is perpendicular, right? Altitude is height. So that means this right here is our right angle, giving us a right triangle. So let's think about what we have here. We know that the length on the x-axis is 4, and we know that the height, or the y value, is 3. So using Pythagorean theorem, or maybe you know this is a Pythagorean triple, we can calculate the length of the hypotenuse to be 5. Okay, and if you needed to do a squared plus b squared equals c squared to get that, that's totally fine also. So now, thinking about the fact that this is theta, we know that no matter what, this is the hypotenuse. Okay, attached to the angle is the adjacent side, and over here is the opposite side. And now we can go ahead and give our trig values. So the sine of this angle, opposite over hypotenuse, is 3 over 5. The cosecant is simply the reciprocal, so it'll be 5 over 3. The cosine of this angle is adjacent over hypotenuse, so 4 over 5. And the secant is the reciprocal of that, so it's 5 over 4. And tangent is opposite over adjacent, so looking at our triangle, that would be 3 over 4. And the cotangent would be the reciprocal of that, so it's 4 over 3. Not too bad. Now, the last thing I'm asking you for is to use any trig ratio to calculate theta. So what you're going to do is you're going to choose one. I don't know, I'm going to choose tangent. We could have picked any one. So I'm going to say the tangent of theta is 3 over 4. I'm using that trig ratio. In order to calculate theta and undo taking the tangent, we take the inverse tan of each side. Inverse tan will always give us an angle measure. So theta equals, and I'm writing this because this is what we're going to put in our calculator, inverse tan of 3 over 4. So in your calculators, you'll say second tan, so second tangent of 3 divided by 4. I got about 37 degrees. I got 36.869899765, blah, blah, blah. So 36.9 degrees. Okay? All right, let's go do another example. So example number 2, we have an angle in standard position. So again, it would start here, and it has a point, negative 12, 5 on its terminal side. So negative 10, 11, 12, 1, 2, 3, 4, 5 is right there. So this is the terminal side. We will attach that back in here. This is the angle, but you can clearly see that the triangle is right here, because we drop our altitude, and now this is our right triangle. Okay, so we're going to call this theta right here, because that's inside of our triangle. And just using the values we were given, it is negative 12. The negative gives it direction, but in terms of the triangle, it is 12 units long, and this is 5 units high. So again, this is actually a Pythagorean triple. You can do 5 squared plus 12 squared equals c squared. I'm not going to do that because I've memorized these, and you should too. 5, 12, 13. With, of course, the 13 being our hypotenuse. The 12 is our adjacent, and the 5 is our opposite. So what I'd like for you to do is pause this video, write out the trig ratios and see if you can calculate theta. Go for it. I actually do want to clarify something. We are going to need this negative on the side for when we put it into the trig ratios. Even though it is representing a triangle, we do have to have that negative there. Okay, so go ahead and do it, please. Okay, so check out the values I got. What you might notice is I always put the negative in the numerator. I just think it's more efficient. So whatever. So, you know, technically you can put it in the numerator, denominator, or out in front. I used cosine of theta equals negative 12 over 13. And I got 157.4. So what I'd like you to realize is that's this angle right here. That started here with its initial side and went here to its terminal side. So if we were asking you for that angle, it would be 157.4. If we ask you for the angle inside, it would just be the supplement to that. And you can clearly look at it and see this has to be an acute angle. So just understand what you're solving for and what we're asking, and you know that'll be really helpful for you. Okay, so example 3, kind of more of the same. Now I'm going to clarify a little bit here because I'm telling you, instead of giving you the angle and the point, I'm changing it up and I'm saying, well, we're in quadrant 3, so I'm not here, I'm not here, and I'm not here. And the sine of theta is negative 4 over 5. So we're going to remember that sine is opposite over hypotenuse. Okay? One rule we have to remember is that our hypotenuse will always be a positive value. No matter which way it's going, our hypotenuse will always be a positive value. So in sketching this, I have to make sure that my opposite side goes down 4 units. So here's my opposite side, right? Because I know theta is going to be here because it has to be along the x-axis. So this is going down 4 units. And my hypotenuse, which of course is always opposite our right angle, will be right here at 5 units. Now, again, we can use Pythagorean theorem to calculate our x value. But again, it's a 3, 4, 5 triangle. It's just that this is in the negative direction, so this will be negative 3. And now it's just the same as we did before. This is our hypotenuse. This is our adjacent. This is our opposite. And I've already given you sine, so cosine's easy. We're just going to flip that over and make it negative. I'm sorry, cosecant. Whoops. Cosecant is easy. We flip that over to be negative 5 over 4. Okay. Cosine of theta, again, adjacent over hypotenuse, so negative 3 over 5. For the secant, we're going to flip that over, right? Write the reciprocal, so negative 5 over 3. Tangent is opposite over adjacent. Notice it's negative 4 over negative 3, so of course you'll make that positive. Tangent is positive in the third quadrant. And cotangent, we're going to write the reciprocal of tangent, which is 3 over 4. Okay, so hopefully so far so good. We didn't ask you to calculate the angle, so we're done. So see if you can sketch number 4 and label the sides correctly. Go ahead and pause the video and let's see what you can do. Okay? Okay, so let's start here. Hopefully you didn't get too far. So labeling the triangle, negative 7 is our x value. That's our adjacent side to our angle. 10 is our hypotenuse, which again, our right angle would be here. And then we'll use Pythagorean theorem to go ahead and calculate this side. This one is not a Pythagorean triple. So we wind up with square root of 51, which can't be broken down, so we just leave it as square root of 51. So now let's go ahead and write our trig ratios. I would start with secant, seeing that we've already been given cosine. So secant of theta is negative 10 over 7. Okay, for sine of theta, it will be, by the way, notice that this is positive because it's going up. I should have stated that before. So sine is opposite over hypotenuse, so square root of 51 over 10. Cosecant will be the reciprocal of that. So it'll be 10 over root 51, and then of course we have to rationalize that. So you'll get 10 root 51 over 51. And then for tangent, it's opposite over adjacent, so root 51 over negative 7. Again, I like to attach that negative to the numerator. For cotangent, it will be the reciprocal, meaning negative 7 over root 51. And once again, you need to rationalize that. So we've got to multiply by root 51 over root 51, which will give us negative 7 root 51 over 51. Okay? And the last one. The last one, we have an angle in standard position whose terminal side lies in quadrant 4. Okay, I gave you the cotangent of theta. Remember, tangent is opposite over adjacent, so this is adjacent over opposite. If you think about the triangle that would be formed, it's going to look something like this. Oops, that's a little squiggly. So this is obviously the negative part, okay? This will be a positive number because it's x going to the right. So cotangent is adjacent over opposite. So this will be 11 over negative 5. So now that you have the diagram, you go ahead and do this problem. See if you can do the whole thing on your own. Okay, and then check back with my answers. So go ahead and pause this video. Okay, so take a look at these answers. Here's our cosine and our secant. Okay, hopefully we got the same answers and you feel comfortable with this lesson. Have a wonderful day, everybody.